Hello everyone, my name is Pranay. I'm from CSC AIML section C, and today my topic is Schur complements of M matrices. Now, how we solve Schur elements of M matrices using block matrices? In block matrices, how we solve using Schur elements or Schur complements? Let's understand. Introduction to Schur complements. Basically, the Schur complement is a powerful concept in matrix theory. It is used to simplify problems involving block matrices. It is named after ICAI Schur. It is named after ICAI Schur. Okay, a German mathematician who introduced in the context of linear algebra. It arises naturally in many fields: linear algebra, optimization, numerical analysis, statistics. The Schur complements helps reduce the large systems of equations to smaller, more manageable forms. Preliminaries. Before knowing how to solve a Schur complements, what are Schur complements, what is a block matrix, we have to understand all this type of context. And let us understand all this type of context using the preliminaries. The preliminaries, before defining the Schur complements, we must understand how matrices can be partitioned and what are block matrices, how we should partition a matrix, and how to partition a matrix. Let's take a block matrix. A block matrix is a matrix that is partitioned into two smaller rectangular matrices. For example, let's take a 2 by 2 matrix A11, A12, A21, A22. The matrix begin with A11, A2, A12, A21, A22. These are the elements of row. So where A11 belongs to R into P into Q, A12 belongs to Q into P, A21 belongs to P into Q, and A22 belongs to Q into P, where P plus Q is equal to N. Okay, you might have a doubt why we should take block matrices for determining the Schur complements. We have to take the block matrices because many real world systems can be divided into interacting subsystems. Suppose if we take anything as a computer or as an any body part, it is divided. Suppose the respiration is done by some other organ, the breathing is done by some other organ, the partitioning of food particles is done by another organ. So in real world and in other parts of world, in Java programs, in many programs, we can make a system into perfect when it is divided into some subclasses. So this block matrices also we divide into some sub matrices. So these block matrices are helpful and can be used and are best example for determining the Schur complements. Okay, it simplifies the computation, the analysis by working with substructures. Okay, now let's partition the matrices. By when we are partitioning the matrices, let's understand how we partition the matrices. For example, partition is not just like taking an arbitrary constant. It is done to isolate variables, simplify system, or focus on key components. Block partitioning often refers to grouping variables, grouping equation, break down large systems of scales into smaller parts. Example content, for example, control systems partitioning into state variables, optimization, constraint versus decision variables, machine learning, joint distribution, visual aid, show a matrix with clear colored blocks A11, A12, and we can see that how large matrix can be broken into small increments. Now let's define the Schur complement. Let's take a matrix A11, A12, A21, A22, okay, with A22 invertible. Let's take that A22 is invertible. Now Schur complement, the Schur complement of A22 in A is AS is equal to A11 minus A12 into A22 inverse into A21. So simple is, again I'm repeating, S is equal to A11 minus A12 into A22 inverse into A21. Similarly, the Schur complement is calculated if A11 is invertible, then we calculate A12 is equal to A11 A22 minus A21 minus A11 inverse into A12. This is how we calculate the Schur complement if A1 is invertible. Now I would like to add an interpretation. The Schur complement is just simplified in a system by eliminating one block of block matrix. This it captures an effect that is called residual effect of the eliminated part. Now there are few conditions there are few conditions required. There are few conditions we have to follow in order to determine the Schur complement. First of all, when is the Schur complement divided? We require some primary requirements. So the primary requirements is, suppose let's assume a case. Here I am having a matrix A. The matrix A, it is having elements A11, A12, A21, A22, beginning with A11 in the first row first element and A12 in the first row second element. Hmm, and beginning with A21 second row first element and A22 second row second element. Okay, and let us consider, I'm considering A122 as invertible, or let's consider as A11 is invertible. Okay, yeah, A11 is invertible. Now the condition of Schur element is what? A22 is equal to Schur element of A11 invertible is S is equal to A22 minus A21 into A11 inverse into A12. This is the condition. Hmm. In case A22 is not invertible, we require some more process. We need to require A22 inverse. We have to use Moore Penrose pseudo inverse if you are not having an inverse. Okay, this is the condition, right? This is the conditions for existence of Schur complement. Okay, now the invertibility of matrix being element is crucial. You need to multiply its inverse. If it is not invertible, you have to use more Penrose pseudo inverse A22 positive. Important notes: the Schur complements are well defined for square invertible matrix. If the matrix is in square or invertible blocks, then we cannot determine Schur complement for it. The overall matrix A does not have to be invertible, but it should have invertible elements. So that is what the line is simplifying us. A22 is singular, that is non-vertible. Basically, it cannot be computed directly. That is what he's saying in upwards for this statement, in contrast upwards. So that is what I wanted to say. If it is non-invertible, it cannot be computed into Schur complement. We need to find Moore Penrose pseudo inverse for that. That is A22 positive for the given element in the matrix A22. That is second row second element. I hope. Interpretation and intuition. Why does Schur complements make sense? Let us understand why they make sense, why they are correct. Let us understand. Right. When we understand Schur complements, we need to understand that, let us think of a linear equation system. Let us think of linear equation system. Okay. Involving two sets of variables. Schur complements allow you to element one set of variables to focus on remaining ones. Suppose let's take an example of matrix A11, A12, A21, A22, and we'll take another matrix x1 and x2. Okay, that is equal to b1 and b2, right? So when we are solving, if you solve for x2, then what happens means, we can substitute, we can take an equation, that a11 a21 a12 a22 into x1 x2 is equal to b1 b2. If you want to solve for that, you will get a reduced system of equation. By getting that reduced system of equation, by substituting that reduced system of equation values given, you can get an easy way to solve your problem. That's Schur complement. It is small example, and let's solve and let's understand this with a small example and end our today's session. Yeah, and I'm going to take a numerical example and explain you step by step. Suppose I have taken a matrix 4 2 3 5. Okay, it is partitioned as A11. First row first element is 4, second row second element is 2, third row I'm so sorry, first row first element is 4, first row second element is 2, and second row first element is 3, second row second element is 5. Right. Now I want to find the Schur complement of A22. Now what is our formula is A11 minus A12 into A22 inverse and A21. Let's take A22 inverse as 1 by 5. Okay. A22 is 5. Let's take A22 inverse as 1 by 5. Okay. Now what is our problem? Let's take the given values. Let's take the values. For example, A11 is 4, A22 is 2, and A21 is 3 and A22 is 5. Let's find A22. What is the given equation formula? We'll get square complement of A22 is S is equal to A11 minus A12 minus A12 into A22 inverse into A21. Right. Our formula is A11. A11 is 4. 4 minus A12. A12. What is A12? It is 2. 2 into 1 by 5 into 3. That is equal to 4 minus 6 by 5. When we solve it, we'll get 14 by 5. That is exactly 2.8. So the square complement of given element S22 A22 is S is equal to 2.8. So this is a simple method we use to solve our problem for the square complement of M matrices and block matrices. And I hope you guys liked it. If you liked it, thank you. I'm very happy, and I hope you liked my presentation, and I'm ending it today. Thank you everyone. Thank you everyone for giving me this opportunity.